Alright guys, welcome to Matheverse, the universe of mathematics. If this is your first time watching our video, thank you for coming and you're welcome. Please do well to subscribe to our YouTube channel, and if you have been here with me, you have subscribed already, thank you for coming back again to watch the video. Alright, so today I'm going to be teaching you variations. Alright, I'm going to be teaching you variations. Now we're going to learn what variations is, and we're going to consider the types of variations, and we'll see the parts of variation we can be able to cover. Now, variation is the change in size, amount, or value of a variable in relation to another variable. All right? Of a variable in relation to another variable. When a variable P is changing, the other variable V is also changing. So, variation is the change in size of P, the size of V, the amount of P, the amount of V, or the value of P, or the value of V, you understand, in a relation. So when P is changing, the relationship between P and V, their changes is the variation we are considering. So there are different types of variations. We have the direct variation, we have the inverse variation, we have the joint variation, and we have the partial variation. So we're going to be considering each of them one after the other. Now let's quickly move to direct variation. Okay, now, direct variation. Let's consider direct variation. Now, what is direct variation? Direct variation is the direct increase of two quantities. If V is increasing, Y is also increasing, but it is direct. This is the direct variation. This symbol here connotes that V is directly variable as Y. So if they tell you V directly variable as Y, when V is this, Y is this. Now find the constant between their variable actions. Now, we have to look at it very closely. So when they tell you V directly variable as Y, this is how it is written mathematically. All right? So now, let's go. When they say V directly varies as Y, it means V is equal to a constant Y. All right? So this constant is what is connoting that V is variable to Y. But it is telling us that V is increasing by this constant. All right? So now let's give ourselves an example so we solve it so you understand it better. All right, now let's look at this example real fast. It said if Y varies directly as X and Y is equal to 24 when X is equal to 6. Now find, we have three sub-questions. Find the relation between Y and X. B, find Y when X is 8. C, find X when Y is 36. Now, let me show you how to answer a question that is directly variable to each other. Okay, now watch. They said Y varies directly as X. And I told you to bring a constant, it will now be Y equals to constant X. Now, when they ask you to find the relation between Y and X, they're asking you to find this constant. Take note. They ask you to find what? This constant. This constant is the relation between Y and X when Y is 24 and X is 6. Now let us find this constant, okay? So now when we solve here, Y is equal to what? 24. X is equal to what? 6. You see it? So Y is 24, X is what? 6. You see that? So the constant K is what we're going to look for now. And to look for K, we have to make K the surrogate of the formula. We have Y is equal to Kx. So we want to make K the surrogate of the formula. We divide both sides by X. We divide here by X. So X cancels X. So K will be equal to Y over X. So K is equal to Y over X. So now let us impute Y and X into this value. When we do that, we'll get K is equal to Y. Y is what? 24. 24 divided by X. What is X? X is 6. So constant is now equal to 6 into 24. That would give us what? 4. So the constant is 4. You will now say, therefore, the relation between Y and X is Y equal to constant will now be 4. 4x. Do you see it? This is the A part. Now let's go to the B part. The B part. It said find Y when X is 8. Now we have gotten the constant. We can now begin to solve for Y when this is that. Solve for x when that is the other one. You understand that now? So we have gotten constant. So with this constant, when they say y is equal to 4x, since we have gotten constant. Now, they now said find y when x is equal to 8. So it will now be y is equal to 4, x is what? 8. So it's 4 times 8. You see that? So y will now be equal to what? 32. We have found y. Now the c part of the question. Let's do the c here so that we can see it clearly. They now said find x. Find x when y is what? 36, right? So now, still using the same formula, since we have found the constant, which is y is equal to what? 4x. So now we already have y. Y, we put it here, that will be 36 equals 4x. Now to get x, what do? We divide both sides by what? By 4, all right? So when we divide here by 4, we divide it by 4. 4 destroys 4. So when 4 goes into 36, that would give us 9. So x here will be equal to 9. You see it? So this is how we're able to solve a question in direct variation. Now we're going to do another calculation, another example again, so that you get it clearly. Okay, now let's look at this example. He said if p varies directly as the square root of q, when p is 16, when q is 4. Now find the formula that connects them. Okay? I told you to get that, it means we have to find the constant. Then we'll now rearrange our formula. So let's solve the A part of this question, which says we should find the formula. They said P varies directly as what? The square root of Q. Then to provide the constant, it will now be P is equal to what? Constant square root of what? Q. Did you see it? So constant square root of what? Q. Now, very easy. So let us solve from this arithmetics we have here. So what is P? P is 16. P is 16. P is what? 16. Q is what? 4. Good job. Now, fix 16 and 4 into this formula, and let's find K. I told you to find K, you have to make what? Q the square root of the formula. And to make Q, we have to divide both sides by the root Q. Square by root Q. So root Q cancels root Q, we have K. So K will be equals to P over what? Root what? Q. Did you see that? So now, we'll have to put P as 16, we'll put it here. Q as 4, we'll fix it here. So that will become K is equal to P is what? 16. What's Q? 4. So it's a square root of 4. You see that? So when we solve 16, which is K, is equal to 16 over, the square root of 4 is 2, right? So 2 goes into 16, that would give us 8. So the constant K is equal to what? 8. So we have found what the constant is. Now, what is the formula connecting them? You say, therefore, the formula connecting them is P is equals to 8 root Q. You see it? You replace that constant with what you have gotten, which is 8. Then you fix it there. That is the formula. We have found constant and we have found the formula connecting them. Now, let us find P when Q is equal to 25. Using the same formula, let's solve. That is B, the B part of the question. Find P when Q is 25. Find P when Q is what? 25. Now, using the same formula, P is equals to 8 root Q. You see? So we are looking for P. P is equal to 8 root Q. Q is what? 25. All right? That will be P is equal to 8 times. The square root of 25 is what? 5. So P will now be what? 40. Did you see it? So this becomes our final answer. So your answer's constant is 8. The formula is P equals to 8 root Q. Then why the value of P when Q is 25 is 40. Did you see it? So this is very easy. It's a very easy question. All right, guys. Thank you very much for watching that video. All right. Watch out for the next video, because in the next video, I'm going to be teaching you how to solve inverse variation. Okay? So watch the next video. Thank you very much.